Hello everyone, welcome back to my YouTube channel. I am Sindhu pursuing my BE in Electronics and Communication Engineering. This video is all about writing verilog behavior description for different types of flip-flops. In this video, we are going to know what is behavioral description, key features of a behavior description such as behavior modeling, structure of a behavior description, the sequential statement and how the sequential statements can be used here, the verilog if format and the case format. First, we see the introduction of a behavior description. It's a powerful tool for describing system where it is difficult to generate digital logic structure. It's a way to describe the functionality of a circuit without specifying structure. The behavior key features of a behavior description. The first one is behavior modeling. It is the highest level of abstraction in Verilog HPL. It is most powerful abstraction in technique, and this description describes how the system behaves according to the input and gives the output. The behavior modeling is done by using two important structure, always and initial. All Verilog statements inside the always are treated as concurrent statement. Any signal that is declared as output should declare it as a register if it is appear inside always. The sequential statements have to be appear inside the always or initial in Verilog. The behavioral description, we do not need to know the logic diagram as in the structural description. Instead, it requires how the output behaves in response to change in the input. Next, we will see the Verilog if format. The execution of if is controlled by the Boolean expression. If the Boolean expression is true, then the statement 1 is executed. If the Boolean expression is false, then the statement A or B is executed. If the statement is only one, then the begin and end can be omitted. If Verilog has only one statement, then begin and end are do not required. Next, we will see the Verilog case format. The case statement is a sequential control statement. It must be included all possible conditions of a control expression. Here, case within bracket we have to declare the control expression. Next, test value and begin statement, and we have to end it here. Then the default statement. Default statement can be used for a confirmation that all conditions are covered or not. Control default statement and begin default statement, and we have to end the default statement here. After default statement, we have to end the case. So this is all about case format. Next is Verilog behavior description for JK type. First, the Verilog module has a declaration and a body. The declaration name, output and input of the module are listed out. The name of the module is a user select. That means we can give any name, but the name of the module should be with alphabet or with any special characters like underscore etc. The input and output are written inside the parenthesis and are separated by a comma, and we have to close the parenthesis by semicolon. First we have to give the module name JK flip-flop. Within bracket we have given inputs and outputs, and then ended with a semicolon. Then the input and output portals are declared, and then always add within bracket we have to give the sequential statement, and then the case we have already seen in before only we have already seen the case format. According to that, we have to declare the case format. So here case within bracket we have to give the control expression, and then the test value, begin statement, and end. After that we have to give this default statement, and then we have to end the case by end case. The module is terminated by predefined word end module, which ends the module. Next is Verilog behavior description for SR type. Here also first we have to give the module name, declaration name, input and outputs within the bracket, and we have to end that parenthesis by a semicolon. Then the input and output portal have to be declared, and then always, and the case format should be written, and then default statement, and we have to end that case, and as well as a module. The next is Verilog behavior description for D type. Here also we have given the module name as DFF, that is D flip-flop, and clock and D are the inputs and Q and Q bar are the outputs, and we have ended with the semicolon. Then always then we have given the sequential statement and the begin statement, and then we have ended this module by end module. The last is verilog behavior description for T type. Here we have given the module name TFF and inputs clock, clear and T, and the outputs are Q and Q bar, and ending with semicolon, and then the sequential statement is declared. And then here we are using the if format, as we know that it is controlled by the execution of the if format is controlled by the Boolean expression. So after if format, we are ending this we are terminating this module by end module. So this is all about the Verilog behavior description for different types of flip-flops. Thank you.